In this problem, we would like to calculate the rotation that is caused by force 45 kilonewton about point A. And as we know previously, the definition of moment is force multiplied by perpendicular distance. And if we look at the question here, it is clear that the perpendicular distance between the force and the point is not mentioned. So we need to resort to a different way in which we will calculate this rotation. We learned from Vernon theorem that when we resolve a force into its components, these components will cause the same amount of moment about a certain force as the force itself. So meaning that we can resolve this force into its x and y component, and we sum all of these moments caused by these components, then we get the same moment of the force. Now step number one is we need to see if we will get any perpendicular distances for these components of the force. Let's first of all do the forces. So if we go and resolve this force into this is x component of the force, and this is the y component of the force, and let's name them. This is fx and this is fy. Of course, we need to calculate the value for these forces before we start to do the sum of moments. So for f1x or fx, it is equal to value f. This is f cosine 30 degrees, which in this case is equal to, force is equal to 45 kilonewton, and of course cosine 30 degrees, and the end result for this is equal to 38.97 kilonewton. And same thing goes for fy, which is equal to f sine 30 degrees, and it is again 45 kilonewton multiplied by sine 30 degrees, and is equal to 22.5 kilonewton. So these are the values for these. We'll accept them to be forces at this point and say this is equal to 38.97, and for fy is equal to 22.5 kilonewton. So we'll treat these forces as if they're independent forces, or they're forces on their own, and see how they will cause rotation about point A. This force will cause a rotation in this direction, which is clockwise, negative, and this will also cause a rotation in the clockwise, which is also negative. So now what we need to do is to do the calculation or the sum of moments about point A. So let's do sum of moments about point A is equal to what? So in this case, we have the first one here, we have fx will cause a negative rotation minus, so it is fx multiplied by the distance. The perpendicular distance is between fx and the point is 15 meters. And for fy is again negative, so it is fy, and the distance between the component fy and A is equal to 3 meters. So again, if we just substitute the values for these, we'll get 38.97 multiplied by 15 minus 22.5 multiplied by 3, and the sum of all moments about A is equal to, of course, minus 652.05, that is kilonewton meter. And of course, the rotation being negative, it means it is rotating clockwise. It is like that. So from this we imply that the sum of all moments about point A is equal to minus 652.